Okay, now we're going to take a look at the sum and difference formulas as they apply to the sine function. So we're going to also prove that. So we're going to need this, and we're going to start with this and do some work here, and then we're going to come over here and we're going to use this, and ultimately we're going to be able to come down here and say we can prove all of this, and that implies that this theorem is true. All right, so let's get started here. Okay, so first we want to say the cosine of pi over 2 minus theta equals the same as the sine of theta. We've actually seen that before, but we've actually got the difference formula for cosine that we can use to show that. We didn't prove it, we just used it. So cosine of pi over 2 minus some angle theta is equal to cosine pi over 2 times cosine theta plus sine pi over 2 times sine theta. And so our cosine of pi over 2 is going to be 0. Our sine of pi over 2 is 1. Okay, so sure enough, by using the difference formula for cosine, we've shown that the cosine of pi over 2 minus some angle theta reduces to, or simplifies to, the sine of pi. I also want to show that the sine of pi over 2 minus theta turns into the cosine of theta. So we're going to take and rewrite the sine of pi over 2 minus theta. We're just going to use what we just proved here. I'm going to write this as this is equal to a cosine of pi over 2 minus pi over 2 minus theta. Okay, so notice how we're plugging in. For theta, we're letting this portion, pi over 2 minus theta, whatever that is, take the place of theta in our cosine statement up here. And then, of course, cosine of pi over 2, I'm taking pi over 2 minus pi over 2, which is 0, and I distribute that negative to theta, and I get this whole thing simplifies to just theta, and that's what we were after here. Okay, so we've shown these, and now we also want to show that the cosine of pi over 2 minus theta is equal to the cosine of theta minus pi over 2. So for this, we're going to keep in mind that the cosine has an even property where the cosine of negative theta is equivalent to the cosine of theta. Okay, we've been using that. So that's what we're going to use here. We're going to take and start with this cosine of pi over 2 minus theta. And I know that that would be equal to a cosine of negative pi over 2 minus theta. Okay, and that is equal to a cosine. Distributing the negative, I would get negative pi over 2 plus theta, but I'm just going to go ahead and put the theta up front. It's positive, and the pi over 2 is subtracted. Okay, so we've shown all of these intermediate steps. So now we're going to take a look and figure out how to derive the sum and difference formulas for the sine function that we see right here. Okay, so now we want to take some of what we looked at here and use it to help us derive the sum and difference formulas for the sine function. So I'm going to start out with a sine of some alpha plus beta. Okay, and what we discovered is that I can rewrite this as a cosine of pi over 2 minus theta, but in this case theta is alpha plus beta. And next I'm going to distribute that negative. So we would have a cosine pi over 2 minus alpha minus beta. And then I'm going to treat this pi over 2 minus alpha as a unit. Okay, so that's still saying the same thing. I've just introduced parentheses here. And now we're going to be able to use the difference formula for cosines. And if I apply the difference formula for cosines, I get cosine pi over 2 minus alpha times cosine beta plus sine pi over 2 minus alpha times sine beta. Okay, and the cosine of pi over 2 minus alpha, I know that simplifies to a sine of alpha, and then this is cosine beta. Sine of pi over 2 minus alpha simplifies to cosine of alpha, and then this is sine beta. Okay, so we were able to show that if I start with sine of alpha and beta, I can derive that that's equivalent to sine alpha times cosine beta plus cosine alpha times sine beta. So that's exactly what's down here. So we start out with plus and we end with plus. So that's a little different than the cosine formula. All right, so we've just taken care of showing this first one here. And what we want to do now is use that to find the second one. So we're going to take and write sine of alpha minus beta. And this will be easy because we can rewrite sine of alpha minus beta as the sine of alpha plus negative beta. And we'll pop this plus into the sum formula for the sine. So using the sum formula that we just created there, we're going to take the sine of alpha times the cosine of negative beta plus the cosine of alpha times the sine of negative beta. All right, the even rule for cosine means this is the same as the cosine beta. So we'll simplify this to sine alpha cosine beta. And then for the sine, it's odd, so I have to bring the negative out in front. So I'm multiplying it by a negative, so we'll just change that plus to a minus. And then we get to call this the sine of beta. Okay, sometimes I put parentheses around it, sometimes I don't. It's the same either way, but there it is.